Welcome in the third video of STM32 Hero series. So this will be your theoretical one, but this will be last theoretical lecture. But this is required because in future videos we will going to develop something on our microcontroller. But you must understand the base. What is STM32, right? This word you heard from many places, like in your college, in your university, in industry. People used to speak like STM32. We have this STM32. But what is STM32? That you must know. You must understand. And for that, I'm explaining you this part. The STM32 is not a chip. First of all, you have to remember STM32 is not a chip. It's a whole family of microcontroller, and it's designed for a different job. So from the images you can see that for remote control we have C0. So again, this is one of the processor series of under this family. Same way for washing machine we have Z0, for drone F4, robot H7. So these all are series. Under this series different microcontrollers are available, but each microcontroller is having fixed type of job. Different project need different chips. Today we explore the toolbox and meet one we are using in this course. So I will just cover over view of this series, this family, and then I will also tell you which microcontroller we will going to use throughout this series and our microcontroller for in which category. Okay. So now next is family group by purpose. So here you can see we have different you can say purpose here: entry level, general purpose, low power, high performance, wireless. In entry level we have CO and GO, or you can say these are cheapest, simplest, good for basic, low cost product like remote and toys. So these are entry level microcontroller series under the family, and they specially designed for cheapest operation like simple low power product, right? They are available with very cheap rate, but they have also limited functionality. So for entry level you should go with this. Then we have general purpose microcontrollers like F4, F1, G4. So these microcontrollers are very popular, most popular, and used in countless hobby and industrial projects. Okay, so these are widely used and very popular. So they are also, you can say, used widely. Then we have low power. So low power means where battery first design. Okay, so wherever you require that your microcontroller, your project or your product should stay long with limited power, then you have to go with this. And under this we have L4 and U5. Okay, so wearable, remote sensors, in this type of application you should go with this. Then we have another high performance. Okay, so our board which I'm going to use throughout this series is fall in this category. It's a F7, right? And these are very top speed and power performance. So wherever you require high performance, like we use maximum clock frequency up to 600 megahertz, right? We need some accelerator to develop some job, right? Some complex operation like even crypto wallet. So this type of thing you have to use high performance device only. Otherwise what happen, if your resources are limited, then at particular point you will not going to develop further, right? They will stuck. So that's why for high performance where multiple sensors are there, multiple complex operations are there, so for that you have to go with the high performance. And under this F7, H5, H7, N6, and again in N6 one AI accelerator is also there built in, so you can use it for this AI related application as well. And this accelerator means on chip some modules is there, and simply you have to configure and use it, right? No need to connect any external device with this. Then next part is wireless. Next purpose is wireless. So wireless is Bluetooth and Wi-Fi. Okay, so now what happen if your microcontroller is want to send something over the wireless medium, Bluetooth or Wi-Fi, so you have to use some external chip, right? But in case of this series WB and WL, these things are inbuilt, okay, within the chip. So you have to simply purchase, simply program, and simply use it. So without any extra chip, you can have this functionality. So for that you have WB and WL series. Now, why so many families? So as I told you earlier, different chips are designed for different jobs. So starting from TV remote to AI camera. So for TV remote, where you need some limited functionality, so you can go with the C0, okay, entry level microcontroller. For washing machine, you can go with Z0 because simple control logic, low cost, matter for mass production, right? So for mass production, if your controller is having low cost, then it would be very good. And again, here functionality is not that type of complex thing, right? So you can go with this series G0. Then drone flight controller, we need F4, okay. F4, again, this designed for real-time requirement, so need real-time motor control, fast, reliable, well supported. So you can go with this F4. Then robotics arm H7, again H7 from high performance category. Bluetooth, here wireless requirement is there, so WB. LoRa field tracker, again wireless requirement, so here WL is the series, right? Then battery sensor, where battery matters, so you can go with this U5. It consumes very low power, right? Then AI camera, so for AI application you can go with N6. So as I told you earlier, with N6 we have AI accelerator, so simply use it and develop your AI thing. Okay, so this is what you can say classification, that for each job different microcontroller you can use. Okay, now our board, which is F767ZI, so it's from high performance group, and as you can see the processor is ARM Cortex M7. Its clock frequency is up to 216 megahertz, RAM 512 KB, and flash memory is 2 MB. GPIO, number of GPIO is 144 pins, ADC 12-bit. Is having communication interface like UART, SPI, I2C, CAN, and again it has built-in ST-Link microcontroller, ST-Link programmer. So without any external chip, you can directly program it. So these all are, you can say, specifications of our board. Again, no need to remember any number, but these are just for understanding purpose, right? So what is there in our microcontroller, and this is again for this part number. And if you go for different board available under this, then this parameter could be slightly vary, but this is from the high performance group only. Okay, now Nucleo board tour. So from next lecture probably we will start using this board practically, because in next we will going to see STM Cube IDE's tool, right? It's our IDE on which we will going to write our program. But this is just a simple basic, you can say, diagram of our Nucleo 144 board which we are going to use. So in Nucleo 144, on top we have ST-Link debugger, where you can simply connect your USB port, okay, and using this USB port you can program your microcontroller, you can upload the code, you can debug the code directly. Then we have LED, LD1, LD2, LD3. These three LEDs are especially designed for interface with GPIO. So on GPIO you can turn on and turn off this LED using the programming. So again, this is for educational purpose, so you can use those LED. Then we have this button, user button, also available. Then reset button is also available on board. Then we have GPIO header. So on GPIO header you can see this CN7 and CN10, and both headers are having multiple IO pins, so you can connect multiple sensor, keypad, LCD, whatever you want to connect. So external hardware you can connect with this GPIO pin. Okay, so this is what the overview of this block diagram of this board, and definitely I will show you the actual board, and we will also going to interface different devices with this, but this is just for this STM32 family related thing. That's why I just discussed it. And where does our board fits? So in this you can see simple to advanced, or the series you can see on right side, and whatever we will develop on GPIO, on UART, on ADC, on timer, on our F7 microcontroller, it will work same way on others microcontroller as well. So if you know how to write or how to send message on over UART for this F7, it will work same way on C0, G0 or F4 also, right? So slight changes would be there, but not that much. And in next episode, as I told you earlier, we will going to see Cube IDE tool, and then we'll start developing actual hardware, actual interface with hardware. So this is what for this lecture. Thank you very much.